This is Geometry, Section 3.2, Properties of Parallel Lines. So we talked about intersecting lines a lot in the last section. Now we're going to be talking just about parallel lines and what happens when we have parallel lines. So if line K is parallel to line W, like we have in this diagram, so we mark that parallel lines are parallel by putting a little triangle on each line like this. That means that they're parallel. You might also just see it like that, a little arrow in the middle of the line. That means that they're parallel. And we can write that K is parallel. We use two slashes. K is parallel to W. So corresponding angles postulate. If we have parallel lines, so for parallel, these two slashes mean parallel, so for parallel lines, corresponding angles, which we talked about in the last section, corresponding angles are congruent. So, for example, if we've got parallel lines and we have a transversal intersecting those parallel lines, corresponding angles would be congruent. For example, this angle is on the top right. This angle is also on the top right of these four angles. These are corresponding angles, so those would be congruent to each other, and that would be true for any of the corresponding angles. Three more theorems. So for parallel lines, alternate interior angles are also congruent. I'm going to abbreviate alternate interior angles are congruent. So same thing for corresponding, alternate interior angles are also congruent. So if I've got parallel lines, alternate interior angles would be angles here and here. Another one for parallel lines, alternate exterior angles are also congruent. So if I had these lines right here, alternate exterior would be this line and this line, which makes sense because this angle is vertical to this angle is vertical to this angle. We already said that those were congruent to each other. Last one for parallel lines, same side interior angles. Same side interior angles are not congruent, but they are supplementary, meaning they add up to 180. So if I have parallel lines like this angle and this angle would add up to 180 degrees together. We remember this one using the phrase same side sup. Same side interior angles are supplementary. So a few diagrams, filling in all of the angles here. So we're only given that this angle right here is 45 degrees. We can go across here and say, well, this vertical angle would also be 45 degrees. First thing that we said was corresponding angles are congruent. So if this angle right here is 45, this angle, which is in the corresponding position up here, would also be 45. And then if we go across vertical angles, this is 45. These two angles are corresponding, so that makes sense that those are both 45. Then we've got to figure out what are the rest of the angles. Well, these two are vertical, so I know those are the same. These are vertical, so those are the same. And all of these angles are going to be supplementary to 45. So how do we figure that out? We've got 180 minus 45 equals all of those angles that we're looking for. 135. So this angle is 135. This is 135 because it's vertical with this. And then if I did the same process up here, I would get that these are both 135. Moving over here. For this one, same thing. So start with vertical angles, 62 and 62. If we look at this, I've got 4 acute angles on this diagram and 4 obtuse angles. Well, I only had 2 different angle measures over here. I had a 45 and a 135, and all of the angles on here were one of those 2 measures. That's always going to happen with parallel lines. So if I look at this, all right, well, this acute angle is 62, so this is an acute angle. That also has to be 62. This is an acute angle. That has to be 62, and this corresponds with this, so those are congruent. And then vertical angles, this is 62. So now I've got to figure out, okay, what are the 4 obtuse angles on here? What number are they? So I take 180 and subtract 62 from it because these 2 angles have to add up to 180, just like these 2 angles have to add up to 180, or these 2 angles, or these 2 angles. So if I subtract that, I get 1 18. So all of these angles are 118 degrees. Same thing over here. Now I'm starting with the obtuse angle. So I know all the obtuse angles on here are going to be 131. So pair up your vertical angles and your corresponding angles. Now I've got to figure out what all of the acute angles are. So same process, 180 minus 131. When I subtract that, I get 49. So all of these acute angles are 49 degrees. This one is a little bit different. So I've got these two parallel lines here, but I've got two separate transversals here and here. So these angles together are going to be related to each other, and these angles together are going to be related to each other, but these angles over here are not related to these angles over here because the parallel lines go this way. So I first have to figure out these 8 angles right here. So if I do that, these are vertical angles here and here. So all of the acute angles over here are going to be 70 degrees. Then I've got to figure out what are the obtuse angles. So 180 minus 70 gives me 110 for all of those obtuse angles. Same thing over here. So this is 80 right here. This must be 80 right here. This diagram isn't very well drawn because this looks like an obtuse angle, but we're told that it's 80. So diagram is not always going to be drawn to scale. So if these are all 80 degrees, then I've got to find the other ones. So 180 minus 80 gives me 100 for all of these. Same thing on this diagram right here. These are my parallel lines now. So these angles go together and these angles go together. So if these are my parallel lines and this is a transversal, this angle and this angle would be considered same side interior angles because they're on the same side of the transversal and they are inside the two parallel lines. So remember that saying, same side sup. So I know this angle and this angle have to add up to 180. So to find this angle that I'm missing, I take 180 and subtract the 89 degrees, and I'm left with 91. So this is 91. And same thing over here with these angles. So this angle would be supplementary to this angle. So I take 180 minus 70, and I get 110 here. Because again, these are same side interior angles. This is my transversal. These angles are on the same side of the transversal inside these two lines. Here we have a 65-degree angle, and we've got these lines are parallel to each other and these lines are parallel to each other. So we've got two transversals going through two parallel lines both ways. So if we use the same side interior thing that we just used before over here, we've got 180 minus 65 is going to give me this angle right here because these are on the same side of this transversal inside these two lines. So 180 minus 65 gives me 115. If I look at this, so if I turn this sideways, all right, well now these are my parallel lines. This is my transversal. These two angles are on the same side of this transversal and inside these two lines. So I can do the same process, subtract this from 180, and I'm going to get the same thing I had originally over here, 65. If I do this again, these are also same side interior angles, so this is going to be 115. So describe the angle pair as corresponding same side interior, or alternate exterior, and find the value of the variables. So first one, we've got these two angles right here. They are on opposite sides or alternate sides of the transversal, and they are inside the two lines. So these would be called alternate interior angles. We can just abbreviate that. So parallel lines means that alternate interior angles are congruent. So we take these two things and set them equal to each other because congruent means equal. So 116 equals 4a plus 20. To solve for a, we subtract 20. We would get 96 equals 4a, and then divide by 4 to get that a equals 24.